Welcome to ASU's University Academic Success Programs. This video will cover the topic, Bronsted Acidity. Many fundamental reactions in organic chemistry are acid-base reactions.
What are the roles of acids and bases in these reactions?
A Bronsted acid donates a proton and accepts electrons, and a Bronsted base accepts a proton and donates electrons. Let's see what this would look like for an acid in water. Here we have hydrochloric acid and water, which acts as a base in this reaction. The oxygen from water will donate electrons and form a bond with the hydrogen from hydrochloric acid. The remaining pair of electrons will be pushed onto chlorine, and we will be left with a chloride anion and a hydronium cation. The chloride anion is the conjugate base of the original acid, and the hydronium cation is the conjugate acid of the original base. Acids and bases typically react because doing so lowers the energy of the electrons. The strength of Bronsted acids and bases is measured in terms of pKa relative to water. The smaller the pKa, the stronger the acid, which suggests a higher likelihood of spontaneous ionization in water. The larger the pKa, the weaker the acid. There are many factors that contribute to Bronsted acidity. To understand nearly all of these trends, we must take the energy of electrons into account. Let's take a look at the periodic table. As atomic size increases down a group in the periodic table, acidity increases. If we look back at hydrochloric acid and compare it to hydroiodic acid, we see that between the two atoms that differ, a chlorine atom is smaller than an iodine atom. This means the bond between chlorine and hydrogen is stronger than the bond between iodine and hydrogen, making hydrochloric acid the weaker acid because it's less likely to dissociate in water. The hydrogen-iodine bond is weaker and therefore easier to break, making it a stronger acid. So here we see that the stronger acid is the one with the weaker bond. Additionally, the stronger acid is the one with the weaker conjugate base. An iodide anion is a weaker base than a chloride anion because it makes weaker bonds.
What else affects the stability of the conjugate base?
One factor is resonance. If a conjugate base is resonance stabilized, it's weaker than a base that has no resonance contributors, because resonance decreases the energy of electrons. This makes the base more stable and less reactive. Stabilization by resonance in the conjugate base is typically the dominating factor when looking at acid and base strength. A more stable or weaker conjugate base corresponds to a stronger acid. This means that the stronger acid has the conjugate base with the lower energy electrons. Another factor that affects the stability of conjugate bases is electronegativity. Let's compare two molecules. If we want to decide which is the stronger acid, we should look at the conjugate bases of each. The key difference here is that oxygen is more electronegative than nitrogen. When the negative charge on a conjugate base anion is placed on a more electronegative element, the electrons are lower in energy and thus the base is more stable, making it a weaker base, and the corresponding acid is thus the stronger acid. So as a general rule, we say that acidity increases as electronegativity increases. When it comes to conjugate base stability, another factor we can look at is hybridization. Let's take a look at two new molecules. Once again, if we want to decide which is the stronger acid, we should look at the conjugate bases of each. The key difference here is the hybridization of the atomic orbital that holds the non-bonding electrons. The carbon on top is sp hybridized, which means the electrons are lower in energy than the ones in the sp2 hybridized orbital on the bottom. Because the electrons in the sp orbital are lower in energy, this conjugate base is more stable and therefore weaker, making the corresponding acid the stronger acid. So, as a general rule, acidity increases with increasing S character of hybridization.
Okay, so it sounds like there are many factors that can influence the strength of a given acid. When we compare acids going down the periodic table, acid strength increases with atomic size. Additionally, we must take into account the energy of electrons in the conjugate base in order to determine acidity. As a general rule, a stronger acid will have a conjugate base with lower energy electrons. A few factors that can affect conjugate base stability are resonance, electronegativity, and hybridization.
That's exactly right. Great work!